Hello everyone, this video is regarding JEE Advanced past year questions on the chapter Trigonometric Functions and Equations Part 5. So the first question for this video. The number of points in minus infinity comma infinity for which x square minus x sin x minus cos x is equal to 0 is. Options are 6, 4, 2 and 0. This is a multiple answer question, so it may have one answer or more than one answer. So what we'll do is initially we'll consider the function to be f of x, which is x square minus x sin x minus cos x is equal to 0. Now we'll find the limit x tends to infinity for this f of x, which will give us infinity, and limit x tends to minus infinity, which will give us also infinity. Now we'll find the f dash of x. F dash of x is nothing but 2x minus x cos x minus sin x minus cos x, differentiation is sin x, so sin x plus minus sin x, so sin x minus sin x is cancelled. So f dash of x is nothing but, if you take x common, 2 into 2 minus cos x. The cos x value cannot be equal to 2, so the x value must be equal to 0. Now if you observe this from this function, in 0 comma infinity in interval, the f of x function is increasing, and if you observe this minus infinity comma 0 function is decreasing. It means that the function will go, it will touch the x-axis at one point in the case of first case, and it will touch and one more point in the second case. So the number of points the function touches the x-axis is 2. So therefore number of points for which this equation has solutions is 2. The answer for this question is 2. Moving on to the next question. Let f of x is equal to x sin pi x comma x greater than 0. Then for all natural numbers n, f dash of x vanishes at. Options are unique point in the interval n comma n plus 1 by 2, unique point in the interval n plus 1 by 2 comma n plus 1, unique point in the interval n comma n plus 1, 2 points in the interval n comma n plus 1. So we have a function f of x which is x sin pi x. If they asked for the f dash of x vanishes at, so first we should write f dash of x. F dash of x is nothing but sin pi x plus x into pi into cos pi x. Now what they asked, vanishes at, therefore f dash of x must be equal to 0. So sin pi x plus pi cos x is equal to 0, which will give us pi x cos x is equal to 0, which will give us tan x is equal to minus pi x. So if you observe, we need the intersection of these two. So tan x graph is nothing but, it will have a minus pi by 2, 3 pi by 2 minus pi by 2 in 2n plus 1 pi by 2, 2n plus 1 into pi by 2 intervals. It will have a infinite value, so there exists no graph at that point. So the tan x is an increasing function, so its graph exists like this. So it will decrease, means it will start from the bottom minus infinity, and it will touch at 0, and it will go to plus infinity at the pi by 2 intervals. So this is a tan x graph, and if you observe pi x graph, it is just a linear graph passing through origin. So if you observe this both graphs intersect that point n plus 1 by n plus 1 comma n plus 1 and n comma n plus 1. So the answer for this question is a unique point in the interval n plus 1 by 2 comma n plus 1, a unique point in the interval n comma n plus 1. So there are two answers for this question, which are B and C. Moving on to the next question. Sin 3 alpha by cos 2 alpha is positive. Option A positive, option B negative. So this is a matrix matching type question. So what we should do is, we should find the cases in which these are positive and the cases in which these are negative. This value is negative. So for that, what we should do, we should find the range of alpha, so that if alpha is a positive, then 3 alpha we should find, and then we should find the quadrant, and from that we can find the whether it is positive or negative in certain interval. So first what we should do, first let us take the option P. Option P is nothing but 13 pi by 48 and 14 pi by 48. So let us consider alpha range. Alpha is nothing but 13 pi by 48, it is in between 13 pi by 48 less than alpha is less than 14 pi by 48. So if you multiply with 3, what you will get, 13 pi by 16 is less than 3 alpha is less than 14 pi by 16. Next, if you consider 2 alpha, 13 pi by 24 is less than 2 alpha is less than 14 pi by 24. So if you observe this 3 alpha will be belonging to quadrant 2 and 2 alpha will be belonging to quadrant 2. So if you observe this, sine is positive in the second quadrant and cos is negative in the second quadrant. So the positive by negative will give us negative. So the first option for this p will have a negative value. So p as answer. Next, if you consider the option q, 14 pi by 48 comma 18 pi by 48. So if you consider alpha, if you consider directly, we'll consider 2 alpha and 3 alpha. 2 alpha is nothing but 14 pi by 24 and 2 alpha 18 pi by 24 and 3 alpha is nothing but 14 pi by 16 comma is less than 3 alpha is less than 18 pi by 16. So if you consider this range may belong to second quadrant or third quadrant, and this 18 pi by 16 will belong to third quadrant. This we cannot say the exact position of this angle, so we should just ignore this option because there is no exact option whether it is positive or negative unless they mention some value. So q does not have any corresponding value, positive or negative, and we'll go to third option, 18 pi by 48 comma 23 pi by 48. So 18 pi by 48 will be have 18 pi by 24 is less than 2 alpha is less than 23 pi by 24. So 2 alpha belongs to second quadrant, and 18 pi by 16 is less than 3 alpha is less than 23 by 16, which implies 3 alpha belongs to quadrant 3. So in quadrant 3 sine is negative and cos is also negative. Negative by negative will give us positive. So the third option corresponds to p. A third option corresponds to a, which is positive. So option A has R as its answer. And if you consider the fourth option, 0 comma pi by 2. So sine 3 alpha is nothing but 0 is less than 0, alpha is less than, 3 alpha is less than 3 pi by 2, 0 is less than 2 alpha is less than pi. If you consider this, we cannot say the exact value, positive or negative in terms of 3 alpha and 2 alpha. So there exists no real answer for this S also. So the answer for this matrix matching type is you have positive only R and you have negative only P. The final answer are A corresponds to R and B corresponds to P. Moving on to the next question. The number of all positive values of theta where 0 is less than theta is less than pi, for which a system of equations y plus z into cos 3 theta is equal to xyz sin 3 theta. X sin 3 theta is equal to 2 cos 3 theta by y plus 2 sin 3 theta by z. XYZ sin 3 theta is equal to y plus 2z cos 3 theta plus y sin 3 theta. Have solutions. X0, y0, z0 with y0, z0 not equal to 0 is. This is an integer type question, so we should be solving and we should get an integer value for this answer. So first what we should do, they give the three equations. So y plus z into cos 3 theta is equal to xyz sin 3 theta. So if you consider this, let us multiply just it with the 2 on both sides. What will get? xyz, sorry, this is equation 1. If you consider the second equation, if you take LCM, xyz sin 3 theta is nothing but 2z cos 3 theta plus 2y sin 3 theta. This is the second equation. Now what is the third equation? xyz sin 3 theta is equal to y plus 2z into cos 3 theta plus y sin 3 theta. So if you observe this, we will do 1 minus 2 and 3 minus 1. Then what you will have? The left hand sides xyz sin 3 theta will get cancelled on this both the cases. So what will be remaining for the 1 minus 2? Cos 3 theta minus 2 sin theta into y, correct? Cos 3 theta minus 2 sin theta into y minus cos 3 theta into z is equal to 0, and sin 3 theta into y plus cos 3 theta into z. So if you observe this, from further simplifying this, what you'll get, cos 3 theta minus 2 sin 3 theta divided by sin 3 theta is equal to minus cos 3 theta divided by cos 3 theta, which implies cos 3 theta is equal to sin 3 theta, implies tan 3 theta is equal to 1. So further simplifying, what you'll get, 3 theta is equal to n pi plus pi by 4, which will give us theta is equal to 4n plus 1 into pi by 4 comma 4n plus 1 into pi by 12 comma n belongs to z. So in the interval they give 0 comma pi, the number of values that exist is pi by 12 comma 5 pi by 12 comma 3 pi by 4. So the number of solutions possible in this is 3. So the answer for this is 3. Moving on to the next question. The number of values of theta in the interval minus pi by 2 comma pi by 2 such that theta does not belongs to n pi by 5 for n is equal to 0 plus or minus 1 and plus or minus 2, and tan theta is equal to cot 5 theta as well as sin 2 theta is equal to cos 4 theta. So they give two conditions. What are they? Tan theta is equal to cot 5 theta and sin 2 theta is equal to cos 4 theta. Now we should find the number of values of theta, and there is also one more condition, which is theta is not equal to n pi by 5. So first we will consider the first condition, which is tan theta is equal to cot 5 theta. So let us simplify this in the form of sin and cos. So what you will get, cos theta cos 5 theta minus sin 5 theta sin theta is equal to 0, implies cos 6 theta is equal to 0, implies theta 6 theta is nothing but minus 5 pi by 2 comma minus 3 pi by 2 comma minus pi by 2 comma pi by 2, because they are given interval minus pi by 2 comma pi by 2, pi by 2, 3 pi by 2, 5 pi by 2. So if you consider the second case, let us write in the form of theta also. What will you get, minus 5 pi by 12 comma minus 3 pi by 12 comma minus pi by 12 comma pi by 12 comma 3 pi by 12 comma 5 pi by 12. These are the values for the first condition. So if you consider the second condition, sin 2 theta is nothing but cos 4 theta. So cos 4 theta is nothing but 1 minus 2 sin square 2 theta. So 2 sin square 2 theta minus plus sin 2 theta minus 1 is equal to 0. So sin 2 theta is nothing but minus 1 comma half. Now for the conditions, you should write 2 theta is equal to minus 1, 2 theta is equal to minus pi by 2, pi by 6, 5 pi by 6, and one more condition is implies theta is equal to minus pi by 4, pi by 12, 5 pi by 12, and if you consider these are the values of theta, we should get the intersection of these both. So the number of common values for these both is 3, which is minus pi by 12 comma pi by 12 comma 5 pi by 12. So the number of values of theta for this question is 3. Moving on to the next question. The maximum value of the expression 1 by sin square theta plus 3 sin theta cos theta plus 5 cos square theta is. So how will we proceed with this sum? First we'll learn something, which is if f of theta is equal to 1 by g theta, then if we need to get the maximum value of g theta f of theta, we need to get the minimum value of g of theta, because it is in the denominator. If you want to get the minimum value of f of theta, we need to get the maximum value of g of theta. So if we know this, if you find the value of this minimum value, it will be the maximum value of this. If you find the maximum, it will be the minimum value of this. So we'll do this sum in such way. So g of theta is nothing but 1 minus cos 2 theta divided by 2, means I am writing sin square theta in the form of cos 2 theta, plus this is nothing but 3 by 2 sin 2 theta plus 5 by 2 into 1 plus cos 2 theta. So I am just writing straight away the steps of this g of theta. So this is nothing but 3 plus 2 cos 2 theta plus 3 by 2 sin 2 theta. So this value must be greater than or equal to 3 plus minus of 4 plus 9 by 4. So the maximum value of this is nothing, g minimum is nothing but 3 minus 5 by 2, which is half, implies f max value is 2. So the final answer for this question is 2. They asked for the maximum value of function, so maximum value is nothing but Moving on to the next question. Two parallel chords of a circle of radius 2 are at a distance √3 plus 1 apart. If the chords subtend at the center angles pi by k and 2 pi by k, where k is greater than 0, then the value of step of k is. So what they give? They give two parallel chords of a circle of radius 2 at a distance. The distance between them is √3 plus 1 into pi by 2. So what we will do is, initially you will draw a circle. You will have two parallel chords of radius 2. This is 2, the radius is 2, and the distance between them is √3 plus 1. Now from this figure what we can get is 2 cos pi by k plus 2 cos 2 pi by 2k is nothing but √3 plus 1, because they gave the distance. Because I am writing this angles to be angles in terms of this pi by k angle and pi by 2k angle in terms of cos, in terms of radius. So which I will get 2 cos pi by k comma 2 cos pi by 2k. So 2 cos pi by k plus 2 cos pi by 2k value must be equal to √3 plus 1. From solving this, what I will get? 4 cos square pi by 2k plus 2 cos pi by 2k minus 3 plus √3 is equal to 0. So cos pi by 2k is equal to minus 2 plus or minus 4 plus 16 into 3 plus √3 divided by 8, minus 1 plus or minus root of 13 plus 4 √3 divided by 4. So for this can be further simplified as minus 1 plus or minus 2 √3 plus 1 divided by 4. So which implies that cos pi by 2k value is equal to √3 by 2 or minus of √3 plus 1 by 2. So they gave pi by 2k is an acute angle, which implies that cos pi by 2k value must be equal to √3 by 2. Therefore √3 by 2 is nothing but pi by 6. So 2k value is equal to 6, k value is equal to 3. So the final answer for this question is 3. Moving on to the next question. So the positive integer n greater than 3 satisfying the equation 1 by sine pi by n is equal to 1 by sine 2 pi by n plus 1 by sine 3 pi by n is. So initially what we shall do is, we will just send this 3 pi by n to this side and we will just simplify that. Later on we will get the sine 2 pi by n and we can cancel and we can simplify it directly. That is what is the idea for this question. So 1 by sine pi by n minus 1 by sine 3 pi by n is equal to 1 by sine 2 pi by n. So taking LCM, what will get? Sine 3 pi by n minus sine pi by n divided by sine pi by n into sine 3 pi by n, which will be equal to 1 by sine 2 pi by n. So which implies 2 cos 2 pi by n into sine pi by n divided by sine pi by n into sine 3 pi by n is equal to 1 by sine 2 pi by n. So further simplifying this, what you will get? 2 sine 2 pi by n into cos 2 pi by n is equal to sine 3 pi by n, which implies sine 4 pi by n. This is nothing but 2 sin a sin b, 2 sin a cos b, which will be sine 2a. Sine 4 pi n minus sine 3 pi by n is equal to 0. Now we got sin c minus sin d formula, which is 2 cos c plus d by 2 sin c minus d by 2, 2 cos 7 pi by 2n into sin pi by 2n is equal to 0, implies cos 7 pi by 2n is equal to 0 or sin pi by 2n is equal to 0. So 7 pi by 2n is equal to 2k plus 1 into pi by 2. We are writing k because we have already n as a variable and we should not confuse with that. Or pi by 2n must be equal to 2k pi. So if we observe this, n value must be equal to 7 by 2k plus 1 or n is equal to 1 by 4k. So they asked for a integer value. So integer value which is greater than 3, which is not possible in the case of second case. So then for k is equal to 0, we get n value to be, in the first case if you keep k is equal to 0, you will get n value to be 7. So the final answer for this question is, the positive integer value is 7. Moving on to the next question. The number of distinct solutions of the equation 5 by 4 cos square 2x plus cos power 4x plus sin power 4x plus cos power 6x plus sin power 6x is equal to 2 is equal to in the interval 0, 2 pi is. So first step what we'll do is we'll convert everything in the cos 2x and cos 3x form, cos 2x and sin 2x form. So we have already 5 by 4 cos square 2x plus, if you write this as cos square a square plus b square, a square whole square plus b square whole square, we can simplify this and we'll get, we have done this a numerous number of times, so it can be written as 1 minus half into sin square 2x plus 1 minus 3 by 4 into sin square 2x is equal to 0. So from this, if you simplify 5 by 4 into sin square 2x cos square 2x minus sin square 2x, which will be equal to 0. Cos square a minus sin square a is nothing but cos 2a. So cos 4x is equal to 0, implies 4x is equal to 2n plus 1 into pi by 2, or x is equal to 2n plus 1 into pi by 8. So in the interval 0, 2 pi, the number of values this x can take is nothing but 0 to 0, 1, 2, 3 and so on 7. So the number of values it can take is 7 plus 1, 8. So the number of distinct solutions it can take is 8. With this we conclude the chapter Trigonometric Equations and Functions. We'll get back to you with the next chapter. Thank you.